Probably not. This is any one circuit element. So V equals IR, it's very useful to put in subscript so that you know that you're talking about the same thing. The voltage on the resistor is the current through the resistor times the impedance of the resistor. Yes? 3. V equals IR, I equals V over R, and R equals V over I. It's a joke. Yes, there would be. And the joke comes from an interesting experience of a now passed away colleague of mine who taught at the Naval Academy. And he was coming in for a physics course where the people had already learned a variety of other courses that were frequently engineering. And so he in his physics course wrote down Ohm's law. And as he was writing down Ohm's law and talking about it, someone asked, which Ohm's law? What do you mean, which Ohm's law? There are 3 Ohm's laws. No 1 Ohm's law. And so then it was explained to him that the 3 Ohm's laws were V equals IR, I equals V over R, and R equals V over I. At which point he had a little internal chuckle to himself, and then every student in the class got 100 on the exam. Wow. So he thought that maybe Ohm's 3 laws is not such a bad idea after all. So ever since then I've joked about Ohm's 3 laws. Okay?
Everyone got 100 on the exam in our class?
Yes.
How is that possible?
That's possible because they understood the subject material so thoroughly that they didn't have to start with V equals IR and solve it. They just knew all combinations and they could just solve it.
Wow.
Are you sure you didn't have a cheat sheet?
Okay, here we go. We need to multiply. What form should we use to multiply? C e to the I5 or A plus IB? C e to the I5. So, the current through the resistor, we just got done saying because it's a series circuit, is the same as the current through the whole circuit. Now wait a minute. Is this equation in peak or RMS?
Either.
Yes!
Oh,
I'm looking for the answer, yes.
Yes.
Okay. The first thing we've been asked to calculate is peak value of the voltage on the resistor, so we're going to make this peak. At some point I'll think ahead and leave room for those keys in parentheses. So in order to get the peak voltage on the resistor, we're going to use the peak value of the current, which was 0.0625 amps. E to the I, 41 degrees. And what is the C, E to the I, 5 format of the impedance of a resistor? R. Therefore, the magnitude of the peak value of the voltage on the resistor is equal to how much?
7.5.
What?
7.5.
Okay, 7.5 more times. 7.5 what? And what is the phase of the voltage on the resistor? I'm going to pluck it out. It is
41 degrees.
41 degrees. Okay? I have left out a calculation at this point. What calculation have I left out? Yes, which says
Determine the RMS voltage.
determine the RMS voltage on the resistor. So the magnitude of the voltage on the resistor as an RMS is equal to 7.5 volts. What do I do? Multiply or divide by square root 2? Divide, because RMSs are always smaller than peak, and so we get what?
5.3.
5.3 volts. Ah, that's where the 5.3 was coming from. It was the RMS. Okay? So what do you think? At this point, you know
Everything.
about the voltage on the resistor. You know that the voltage on the resistor oscillates between plus 7.5 minus 7.5, meaning that it has a root mean square value of 5.3 volts, and it does so 41 degrees off. And that means 41 degrees in the direction of current first, voltage later. Okay? Yes? Yes. The question was, if we had chosen to do this by writing RMS in this equation, and we had put IRMS here, would we have gotten 5.3 there, and then multiplied by square root of 2 to get 7.5 for the peak? And the answer is sure. Absolutely. Yeah. Yes. All phases are being measured as compared to the power supply. And the power supply is phase of 0. Because really, when you've got some AC circuit, you don't care at the time when Lilco turned on. You know what I mean? This thing has been going up and down 60 times per second, the electrical outlet, for years. So I don't wish to say, oh, but what was it when the building first threw the breakers? Was it sine or cosine at that point? I don't care. If I hook a circuit into it, then I can say that as compared to the phase of that, something in the circuit is what it is. So we fix the phase of the power supply, whatever it happens to be. And then this is with respect to that. Okay? So, yes? Because I need to define the RMS value. And the 7.5 volts was the peak value. So RMSs are always smaller than peak by a factor square root of 2. So whenever you have the RMS value of something, you can automatically find the peak. Whenever you have the peak value of something, you can automatically find the RMS, because you know that it doesn't matter what the quantity is, the ratio between peak and RMS is square root of 2. So we happen to solve for peak first, and then divide by square root of 2 to get RMS. We could have done this in the other order, solve for RMS first, and then multiply by square root of 2 to get peak, by just using the RMS current. Okay? So far, so good? Yep. There is one thing that we have not calculated. The voltage on the inductor. The capacitor. VC equals VC is ICZC. Somebody shouted out peak. I was about to ask the question, is this formula in RMS or is it in peak?
Yeah.
Yes, it is in RMS or it is in peak. And I had a shouted suggestion, let's do it in peak. So therefore, what is the formula for the peak current through this circuit? Now, since this is a series circuit, the current through all elements is the same, so the current through the capacitor is the same as the total current, so we get
0.0625 and e to the I-41 degree.
And now we need the Z of the capacitor. Should this be in CE to the I-phi format, or should this be in A plus IV format? CE to the I-phi, in which case, that's the constant. And E to the I, remember we're in the Euler forgive me format. And so what is that? Minus pi over 2, but we're in the Euler forgive me format. 90.
What happens to the negative in front of the 1 over omega c?
It's a the magnitude? Magnitudes are always positive. And the negative is found right there. Okay? So, what is the magnitude of the peak value of the voltage on the capacitor? One over omega C was 106 ohms, is that right?
Yes.
If I'm remembering from the beginning. So, what's the magnitude of the peak voltage on the capacitor?
Is 106 times 10625.
Yes, I agree. But I want you to multiply for me.
6.63.
How much?
6.63.
6.63 volts. And now what is the phase of the voltage on the capacitor?
Negative 49 degrees.
Equals how much?
Yeah, minus 29.
Because e to the I 41 times e to the I negative 90 is e to the I 41 minus I times 90. You factor out the I, and the phase is 41 minus 90.
Yeah, why is it
Oh, why is it 90? Because it's the Z of a capacitor. I've long since erased the board. Yes, the Z of a capacitor is always 1 over omega C e to the I negative pi over 2. Okay, and pi over 2 is 90. So e to the I negative pi over 2 is e to the I negative 90. And e to the I pi over 2 for an inductor is e to the I plus 90. So as long as, I thought people would feel a little bit better if they saw degrees. So even though mathematicians, we're going to have to erase this before they come in so that, the pitchforks and the torches aren't broken out against the physics department. But I think you know what I mean by the notation, and the gut feeling, I think, is coming through to you better at this point than if there are radians involved. Okay? Yeah?
Yeah, first of all, I'm going to have to go back to some reading. They all.
Well, this was partly a choice here, right? I could have been in radians all the way through.
Okay.
I guess in order to make grading easy, which is a good thing on the final, I'll probably specify what format you should put such answers in. Okay? So now, what is the RMS value of the voltage on the capacitor? So I take the peak, divide by square root of 2 or multiply? Okay. At this point, we've found out all possible numerical values. We have found every quantity as a peak, an RMS, and a phase. Peak, RMS, phase, peak, RMS, phase, peak, RMS, phase, peak, RMS, phase. Now, we have more questions. The next question is, if the voltage across the capacitor is used to power another circuit, would this system be considered a high-pass or a low-pass circuit? Now, how do we figure that out? What aspect of a capacitor and or a resistor do we use?